Right, compound inequality, here's what it is. It's two distinct inequalities joined by and or. So when you say things like, the baby car seats are for kids between 15 and 25 pounds. That's a compound inequality. Or if you say that we need to spend either 4 hours on the project or less than 2. That's a compound inequality. You add an or in there. So and or ors. And so when we go to solve these, you'll be, it's 2 for the price of 1. Instead of 1 inequality, you solve, you have 2. And then the graphs will be different. So the and graph, the solutions are the overlap of the 2 inequalities. So and means intersection. The and means intersection or overlap. And for the or, the graph or solutions are each of the 2 inequalities rather than the overlap. So it's both of them together. So in many cases on the ands, you'll have something like this. You might have between this value and this value graph. Not always, but oftentimes it looks like what we call a curl bar. It has a curl bar look. It's got little dumbbells on each side and a bar in between. And then the or, oftentimes the ors will go in opposite directions like this. Might look like this. Not always. Sometimes these points could be swapped so that you end up with the whole number line as the solution set. But the ors oftentimes look like that. It's less than this value or greater than that value. So you don't want any of the stuff in between, but it's both of these. Okay, there's a shorthand notation, we call it interval notation, that's used in place of inequalities. So instead of writing compound inequalities, we can use a little bit of shorthand. And a couple things you need to know on these. Let me define it first here. The interval notation is used to describe an interval on a number line, just like inequalities. So used to describe an interval on a number line. There are a few different mathematical symbols that will show up when you're working with interval notation. One of them is parentheses. So parentheses work the same as a less than or greater than. The endpoints are not included. So the parentheses, this is a parenthesis right here, or rounded parentheses, or we call them open parentheses in higher level math. That's another way of saying we want all the numbers greater than -2, but in this case less than or equal to 5. The brackets work the same as less than or equal to or greater than or equal to. The endpoints are included. And that little sideways looking 8 is what we call infinity. And we use, this is positive infinity if the interval continues forever in the positive direction, and negative infinity if it goes forever in the negative direction. So we're going to draw an interval on a number line for each one of those interval notation examples that we have next. Alright, so going back over here, -2 to 5, here's what this would look like. There's 0 right there. There's -2. 1, 2, there's 5 right there. So go ahead and draw that number line going from -2 to 5 if you could. Now it says the parentheses work the same as less than or greater than. Endpoints are not included. So on this number line graph at -2, see how we have a parenthesis here? That means we'll have an open circle at -2. Whereas the brackets work the same as less than or equal to or greater than or equal to. The endpoints are included. In this case, what we're saying in interval notation is it's the number or solution set is greater than -2 and less than or equal to 5. So we'd have a closed dot at 5, and we would be shading everything in between. Okay, so that's what the interval on the number line would look like, corresponding to that interval notation, -2 to 5. What would change if I made this over here a bracket instead? What would change? Yeah. Be a closed circle, yeah. And then another option would be if I made this open over here, what would change? Yeah. It'd be open circle over here, yeah. So that's just a shorthand way of writing out what's called the compound inequality. So I'll show you the inequality way in a little bit here. We're going to do that. The next number line here, you can just draw a number line, just a generic number line. Place 3 anywhere on there you want to. And am I going to have a closed or open circle at 3? Closed circle at 3. And then it says down here, use infinity if the interval continues forever in the positive direction. So this infinity means it continues forever in the positive direction. So we would just go like this, shade to the right, and it just keeps on going. This is equivalent to saying x is greater than or equal to 3. This says the same thing as that. And the last one on here, here's 0, 1, 2, 3, 4, 5, 6. Draw that number line from 0 to 6. And so this describes the interval starting at 0, going all the way to 6. To add one more in here. We're missing a case where we have a negative infinity. So something like this, negative infinity up to 2. What would that look like? Draw a number line to go with that. place 2 somewhere on the number line, maybe towards the middle. But here we would have an open circle at 2, and we would go in the direction of negative infinity, which would be to the left. That represents the different cases you might see with interval notation. Could you interpret what this says with an inequality? The x is, what symbol would I use? Less than, yeah. And then you'd be done. So these are the same thing. Right, any questions about interval notation? I know that's new. Something that'll show up again later on as you move through your math courses. All right. We're going to write a compound inequality that represents the phrase, not interval notation, but using inequalities. So here we go. We're going to do this together. It says all real numbers. I'm going to use all real numbers. That's going to be represented by the letter just x. Okay. So all real numbers that are greater than. So greater than would be that symbol, and then negative 2. So we have x is greater than negative 2, and basically this whole phrase again, all real numbers that are, let's stop right here at r, less than 6. So that would be x less than 6. So that is called a compound inequality. That's one way to write it, as 2 separate inequalities. There is a way to join them together, which I'm not sure if you've seen before. You may have. But the way we join these together is like this. We place the x in the middle. We have the less than 6 here to the right. And then if I take this inequality and flip it around so it's pointing the other direction, at the negative 2, I have the same thing that I've expressed up here in red. This says x is between negative 2 and 6. So you can write a compound inequality as 2 separate statements with an and, or in the and case, you can join them together as one with the variable in the middle. Notice that both inequalities are pointing the same direction. You shouldn't have them where they're pointing opposite directions in this and case, okay? So let's go ahead and graph it here. If I place 0 right here, negative 2 would be here. 1, 2, 3, 4, 5, 6 is right here. And so I have an open circle at negative 2. It says x is greater than negative 2. And an open circle at 6. And I would shade everything in between here. So my solution set looks like that. So in the very first problem in your classwork, I'm going to ask you to do that, is write the inequality. It'll either be an and or an or, and then graph it. Here's what the or looks like. It says all real numbers, right, x, that are less than 0, so less than 0, so x less than 0, or, so we write down the word or, all real numbers x that are greater than or equal to 5, so x greater than or equal to 5. So I've got this part right here, and then we've got the less than 0 right here, separated by an or. Now the ors, we don't join those together. We just leave them separated out. And I think it'll make sense when you see them graphed. If I place my 0 right here, x is less than 0 would look like this. Open circle, going to the left. X greater than or equal to 5 would look like this. 1, 2, 3, 4, 5. Open circle, going to the right. right, we're going to do these next two together just for a couple more examples here. It says all real numbers that are greater than or equal to -4. So all real numbers would be x that are greater than or equal to, there's the greater than or equal to symbol, -4, and less than 6. So that's going back to all real numbers less than 6. So there's one way to write it. If I wanted to write it so that x is in the middle, I would just match the x less than 6, and then I've got to flip the inequality here and place the -4 on the left. Make sure that the smaller number is on the left there. It goes from -4 up to 6. So if 0 is right here, -4, 1, 2, 3, -4 is right here. We have a closed circle at -4. And 1, 2, 3, 4, 5, 6 is right here. Open circle there. Shade everything in between. That's an AND statement. This time we have all real numbers, x, we'll use x for that are less than or equal to 2.5. So less than or equal to 2.5. Or all real numbers that are greater than 6. So all real numbers x greater than 6. You write two separate inequalities separated by an or. I place 0 right here. 1, 2, 3. 2.5 would be halfway in between 2 and 3. Closed circle right there. Shade to the left. X is less than or equal to 2.5. Or 4, 5, there's 6 right there. We have an open circle at 6. All real numbers that are greater than 6 would be to the right of that. So that's translating the words into a compound inequality. Alright, now here's a compound inequality that we're going to solve. We're going to solve this first and then go ahead and graph it. So if I break this out, here's what this says. This is -3 is less than or equal to m minus 4, and m minus 4 is less than -1. Okay, so literally this can be interpreted as two separate inequalities separated by an and. I'll show you on a next problem here how you could keep it all together. But this is what it means. It's an and statement. Pretty easy to solve. There's two of them, but they're both easy to solve. So we add 4 to each side. This is a 1. So I have m is greater than or equal to 1. Switch it around here. Should say m is greater than or equal to 1, and let's solve this one. Add 4. M is less than 3, so we have m is greater than or equal to 1, and m is less than 3. So we solve them both separately after you've split them up into two separate cases. Place 0 on the number line here. 1 is right here. 3 is here. So this says greater than or equal to 1. So closed circle at 1. Less than 3. Open circle at 3. And we would shade everything in between. So when you see it written like this, it means we're working with an and. You might circle the and there. Jacob, we're going to do all of the classwork except for number 11. And that will be classwork and homework today. You do not need to do the bookwork yet. We'll work on that tomorrow. We're going to spend another day on this tomorrow in class. All right. Here we go. We're going to try this one. So if I split this up, what are my two inequalities I got to solve? Just give me one of them. And then you have to insert the and in there. So when you see it looking like this, it's an and. 3y minus 4 is less than 14. So notice these are both the same here and here. I'm going to solve them. So two-stepper, add 4. You got 2 is less than or equal to 3y. Don't panic because 3 doesn't go into 2 evenly. It's okay. So I've got 2/3 is less than or equal to y. And, or from y's perspective, y is greater than or equal to 2/3 or bigger than 2/3. Here add 4. 3y is less than 18. Divide by 3, divide by 3. Y is less than 6. So I'm going to be between 2/3 and 6. So if I place my 0 here, here's 1, 2, 3, 4, 5, here's 6. So 2/3 would be just a little bit less than 1. Place a closed circle somewhere in between 0 and 1, closer to 1. And then I've got an open circle at 6. And because it's an and, I'm going to get everything in between here, the overlap only. So those are your ands. I have a couple of those to do it. A few of them, actually. All right, here's a real-life sort of problem here. Writing and solving a compound inequality. It says, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. So that's saying, you know, maybe your homework score is down in the C range. So you need to get a something between 84 and 86 on your test average to bring that up so your overall grade is a B or something like that. So it's inclusive. You've scored the following 3. Go ahead and write this down. 86, write it right in the middle, plus 85, plus 80. So you've been scoring in the 80s. The question is, what do you need to get on the 4th test? We'll call that X. To get an unrounded average or unrounded test average between 84 and 86. So 1, 2, 3, there's 4 tests. You've got to divide by 4 to get the average. And you want to stay between less than or equal, well, yeah, I guess you could try and get better, but you're going to have to get between 86 and 84. So this is what we call a compound inequality. And there is a shortcut for solving these. Rather than breaking this into 2 pieces like I did earlier, we can solve it all at once. You may have seen this before. It looks like this. I'm going to add these up. If I add these 3 up, it's 251 plus x all over 4 less than or equal to 86. So we're kind of simplifying this. We have 2 more steps we need to do to solve for x. Find out what x needs to be between what 2 scores to have an unrounded test average between 84 and 86. So first step, this is going back to our equation solving, we want to get rid of this 4 on the bottom. So we're going to multiply each piece here, the 84 by 4. We're going to multiply the 251 plus x over 4 by 4, and we're going to multiply the 86 by 4. So 4 times 84 is 320 plus 16 more, 336. The 4's here cancel, leaving 251 plus x. And then this is 344. 320 plus 24 is 344. So that's the first step, is multiply through by 4. And you can do it to all 3 pieces of this. Okay, so that's a little bit of a shortcut if you don't want to break it into 2 inequalities separated by an and. Okay? Then I'm going to subtract 251 from each and every piece. And so I have x in the middle, And 336 minus 251 gives me, that's 85. And 344 minus 251, I believe, is 90, is that 93? Yeah, 93. So what this is saying is you must earn between an 85 and 93 on the fourth test. Fourth test. To stay between 84 and 86 is your unrounded test average. So, all right, in the interest of time, we're going to skip over the now you try here. That's an example of a compound inequality, kind of what you might see in real life. All right, we're going to look at an OR statement here. It says, what are the solutions to the inequality? This is separated by an OR. So we're just solving both of them. You're not trying to join them together. The graph will look different than it did on the AND one. But subtract 2 from each side. So 3x is less than negative 9. Then divide by 3. So x is less than negative 3. Or over here we would subtract 5 from each side. And then we have to remember that when we divide each side by negative 4, we've got to change or reverse the inequality direction. We've got x is greater than 1. So x is less than negative 3 or x is greater than 1, and we're going to graph that. So place 0 right here. We've got negative 3 right here. 1 is right here. So we've got x is less than negative 3. So open circle at negative 3. Graph to the left. And x is greater than 1. Open circle at 1. Graph goes to the right. We're going to go ahead and do one more here. Subtract 7 from each side, so you have negative 2y is less than negative 6. When I divide by negative 2, I reverse the direction. So y is greater than 3. Or, over here, subtract 3. 4y is less than or equal to negative 8. And then divide by 4. So y is less than or equal to negative 2. And notice how the graph looks here, how it compares to the AND. So we have negative 2 over here. Y is less than or equal to negative 2, so closed circle going to the left. 3 is over here, open circle going to the right. Right, so this is the last example. Using interval notation. So towards the end of the classwork, I'm going to ask you to do this classwork. It'll become homework too, or you can finish it for homework. It says, what is the graph of negative 4, 6? So far left end is going to be negative 4. Let's place 0 right here. 1, 2, 3. Here's negative 4. Do you remember what the bracket indicates? Closed circle. So it's closed circle at negative 4. 6. 1, 2, 3, 4, 5, 6. Because it's a parenthesis, it's an open circle at 6. And we're going to shade everything in between. So then it says, how do you write negative 4, the interval negative 4, 6 as an inequality? Well, you place x in the middle here. And right here, this part says x is less than 6, but greater than or equal to negative 4. If you think of all the shaded goop here as the x, the endpoints are the negative 4 and 6. It's x is between negative 4 and 6 here. And the negative 4 has x is greater than or equal to negative 4 there. All right, what is the graph of x is less than or equal to negative 1 or x is greater than 2? And we're going to write the inequality in interval notation. So place 0 right here, negative 1 is here, 2 is right here. So this says x is less than or equal to negative 1, so close circle at negative 1. You would shade to the left. Open circle at 2, and you would go to the right. So there's a little symbol that we use called the union symbol. It looks like that for our OR statements. Okay, it's a union symbol. The union. And it replaces the OR. So way over here to the left would be negative infinity. And it goes up to negative 1. Union, so OR, I'm starting at 2 right here. I'm going to use a parenthesis for the 2 because it's not filled in. And then way to the right, if I keep going to the right in positive direction, what symbol represents that? Infinity, yeah. So that's what it looks like. What about here? The graph of negative 2, 7. So we'd have negative 2 right here. 1, 2, 3, 4, 5, 6, 7 here. Open circle at negative 2. Close circle at 7. And we would shade everything in between. And if the everything in between is represented by x, x has to be bigger than negative 2, but less than or equal to 7. And then what is the graph of y greater than 7? So if this is 0 here, 1, 2, 3, 4, 5, 6, here's 7. We just have an open circle at 7, and we would just be going to the right. If we write that in interval notation, it would go 7, parentheses 7, comma, keep going to the right means infinity.